to increase or decrease without bound, and asymptotes. I already introduced this in the previous videos, but we are not unloading all information, all chunks of information about limits in one video. We don't have to do that. We have all the time for this. Increasing without bound. A function increases without bound if and only if the limit of our function as x approaches a from the right is equal to infinity, or if the limit of our function as x approaches a from the left is equal to infinity. This function, f of x is equal to 1 over x plus 2 raised to 2. This is a rational function. And you know that this function is going to be undefined when x is equal to negative 2. So you know what's going to happen. You cannot evaluate the function exactly at negative 2 because it's going to be undefined. So what you do is you get close to negative 2. Okay? The limit of this function as x approaches negative 2 from the left. Okay, so this is your horizontal axis. You will approach negative 2 from the left, and your function goes to infinity. That is telling you that the line x, which is equal to negative 2, is a vertical asymptote. Similarly, when your x approaches negative 2 from the right, your function approaches or goes to infinity. So when your function behaves this way, your function increases without bound. So your function increases without bound if and only if the limit of your function as x approaches infinity is infinity. Okay, so here, when our x approaches infinity, your function has a value because this is a polynomial function. The domain of the polynomial function is the set of real numbers. So as x approaches infinity, your function goes to infinity as well. It is increasing without bound. And similarly, when your x approaches negative infinity, your function approaches positive infinity. So when you have functions like this, functions that behave like this, you will say that the function increases without bound. Decreasing without bound. A function decreases without bound if and only if. Okay, so this one is a function defined by your f of x is equal to ln of x. So when x is equal to 0, ln of 0 is undefined. So you cannot evaluate your function exactly at x is equal to 0. But we can investigate the behavior of your function as x approaches 0 from the right. Okay, from the graph, it is telling you that the line x is equal to 0 is a vertical asymptote. And in this case, as x approaches 0 from the right, your function goes to negative infinity. So when you have functions that behave this way, that function is a function that decreases without bound. Your function decreases without bound if and only if this is true. So let's say, for example, this one. This one is a rational function whose vertical asymptote is x is equal to 0. Okay, so as x, or when x approaches 0 from the left, our function approaches negative infinity. But on the other side, as x approaches 0 from the right, our function goes to infinity, or our function increases without bound. So your function decreases without bound if and only if the limit of your function as x approaches infinity is negative infinity, or when x approaches negative infinity, your function goes to negative infinity. Okay, so in this case, again, this is a polynomial function. And polynomial functions are defined for any real number x. So in this case, as x approaches positive infinity, your function goes to negative infinity. It decreases without bound. On the other side of your graph, when x approaches negative infinity, your function, or the value of your function, goes to negative infinity, or another way of saying it is your function decreases without bound. So you're already familiar with vertical asymptotes. Although you studied vertical asymptotes in relation to where your rational functions are undefined. Okay, but here we are defining your vertical asymptotes using the concept or the idea of limit. So the line x is equal to a is a vertical asymptote if and only if this is true. The limit of your function as x approaches a from the right is equal to plus or minus infinity, or when the limit of your function as x approaches a from the left is equal to plus or minus infinity. And we see a lot of vertical asymptotes in rational functions and also in circular functions. Can you still recall your tangent functions, your secant and your cosecant? So in this function, which is defined by this, we know that this is going to be undefined when x is equal to negative 2 or when x is equal to 2. Because when this is negative 2, negative 2 squared is just 4, and 4 minus 4 is 0. So that brings you to division by 0, and that is undefined. It's the same when x is equal to 2. 2 squared minus 4 is equal to 0. But in terms of limit, this is how our function behaves in relation to the vertical asymptotes. So as x approaches negative 2 from the left, your function goes towards infinity. But you can also approach negative 2 from the right. As x approaches negative 2 from the right, your function goes to negative infinity. So this line here, this line is a vertical asymptote. And we have another vertical asymptote. It's the line x is equal to 2. As x approaches 2 from the left, okay, your function goes to negative infinity, or your function decreases without bound. When x approaches 2 from the right, your function increases without bound. So that is how we are defining the vertical asymptotes using limits. How about your horizontal asymptote? So the line y is equal to b is a horizontal asymptote if and only if the limit of our function as x approaches positive infinity or negative infinity is equal to b. Okay, so it's something like this. When x approaches infinity, okay, we will pay attention to this part of the graph of our function. And if you were to look at it, it doesn't decrease without bound. It is kind of bounded. And in fact, it is bounded by the line y is equal to 2. That is your horizontal asymptote. It's the same way in this side. When x approaches negative infinity, your function does not decrease without bound. It is bounded. Bounded by what? Bounded by your horizontal asymptote, which in this case is the line y is equal to 2.